This is a key to worksheet topic 2, part 1. In this worksheet, you have to solve each of these rational equations. So let's look at number 1. So number 1, you have this rational equation, and notice that you have fractions. And so when you have fractions, the first thing you want to do or the process you want to go through is to clear the fractions. Now notice though that in the denominators you have the monomial factor x. So these are monomial factors. So you have x. You can think of this denominator as 1, 2 divided by 1. You have the monomial factors 3x, and you have 2. So if you want to clear the fractions, you're going to have to multiply both sides by the least common denominator. All right, now keep in mind that in the directions it does say to use the least common denominator. So make sure that what you're using is the least and not a common denominator. So if you look at x, 3, x, and 2, again, so I'm looking at each factor. So the factor here is x, the factor here is 1 in the denominator. In this denominator, there are two factors. There's a factor 3 and the factor x, and then there's a factor 2. So if you just look at the coefficients first, 3 and then the constant 2, the smallest number that 3 and 2 go into is 6. So in my least common denominator, I have the factor 6. Now, if you look at the other factors, you have x and you have x, and so you need a factor of x. And so that's going to be the least. So notice x goes into 6x, 3x goes into 6x, because 3 goes into 6 2 times, and x goes into x 1 time, and then 2 goes into 6x, because 2 goes into 6. All right, so that's your least common denominator. The other thing you had to do was find the restriction. And so basically, to find the restriction, you can do one of two things. You can go to each denominator and determine what makes that denominator 0. So if you look at this denominator, remember a rational expression is undefined when the denominator is 0. So the question is, when is x equal to 0? Well, x is equal to 0 when x is 0. So that's your restriction. So x cannot equal 0. And then you go to the next one, the same thing here. 3 times what is 0? Well, 3 times 0 is 0, and I already have it listed. If you look at this denominator, there's no variable there, so that means that this is never going to be 0. So then there's no number for x here that will make this denominator 0 because there's no x. It's just a constant 2. The other way you can do this is once you find the least common denominator. Now here's the tricky part there. Suppose you found an incorrect least common denominator. Then if you use that to determine your restriction, you may have an issue. It may be incorrect. So most students just look at each of these denominators and they determine what makes that 0. But basically all you have to do, if your least common denominator is correct, you just have to set that equal to 0 and solve for x. So when I solve this equation for x, I divide both sides by 6, I get x to be 0, and so that's your restriction. Okay, so once you find both of these, then the next thing you want to do is to multiply both sides by the least common denominator. Now notice that in this side there are 2 terms, and on this side there are 2 terms as well. So I'm going to use parentheses. So I'm going to put this in parentheses. I'm going to say 3 divided by x plus 2, and then you multiply that by 6x. And again, what you do to one side, you have to do to the other. And do the same thing here. So 6x times this side, 7 divided by 3x minus a half. All right, now the next step, notice I have some parentheses here. So now I got to get rid of the parentheses. So that's where you use the distributive property. And so actually write in this next step. Don't skip the step. Write in this next step. So you're going to say 6x times this first fraction plus 6x times the next term, which is 2, equals 6x times the first term, 7 divided by 3x, minus, and then 6x times a half. All right, so basically, remember, you're multiplying every term by 6x, and that's what you see here, 6x times 6x times 6x times 6x. Now the next step is to reduce, and so you have to show this. So you're going to say x divided by x is 1, you're left with a factor of 1, x divided by x is 1. Over here, there's nothing to reduce. Over here, I can reduce. 3 into 3 is 1, 3 into 6 is 2, x and x is 1, x and x is 1. And over here, I can reduce the 2 into the 6. So 2 into 2 is 1, 2 into 6 is 3. Now remember, the whole point of multiplying by the LCD is to clear the fractions, is to make all these denominators here factors of 1. And notice they're all factors of 1. So that means when I go from here to the next step, I'm going to have this. 6 times 1 times 3 is 18, plus 6x times 2 is 12x, equal 2 times 1 times 7 is 14, minus 3 times x times 1 is 3x. So that's where I'm at. So notice I clear the fractions. I don't have any fractions here. It's a nice linear equation. So I went from a rational equation to a linear equation. And so notice this is now linear. And so to solve a linear equation, we bring all the variables to one side, constants to the other. And so when I add 3x to both sides, let's do that first. I get 18 plus 15x equal, combined like terms, this is 0, 14. All right, now to bring the constants to the other side, let's go ahead and subtract 18 from both sides. And so when I combine like terms, this is 0. 0 plus 15x is 15x equal, and then 14 and negative 18 is a negative 4. And then to get the variable x by itself, right now multiplying by 15, the opposite is to divide by 15. And so I get 15 divided by 15 is 1. 1 times x is x, equal negative 4 15ths. And if you can reduce, you reduce. I cannot reduce here. So that's your answer. So that's your solution. All right. Now, let's just say this. You might say, well, why did we have to find the restriction? Well, whenever you're solving a rational equation and there are variables in the denominator, if this right here, if this, now remember, this is a solution to this, but it may not be a solution to the original problem. So it's a solution to the linear equation, but it may not be a solution to the rational equation because of the restriction. So all you have to do is just check to see if this is your restriction, and it's not. So as long as you think the work is correct here, that's your solution. Now, you can check by substituting this value into the original equation, but then it's going to become very complicated. So I'm not going to go ahead and check here because it will take some time. So that actually is a solution. So that's number 1. Okay, let's look at number 2. Okay, so number 2, again, you have this rational equation. And so you have fractions here. You have at least one rational expression. In fact, you have many. And you want to, first of all, find the least common denominator. So you want to solve this equation by first clearing the fractions. So to do that, you're going to multiply both sides by the least common denominator. And so the least common denominator, if you look at all these denominators, those are all monomial factors. So that's an easy kind. So those are the easy kind when the denominators are monomial factors because there's nothing to factor. So you have 4, a factor of 4, a factor of x, a factor of 2, a factor of x, and a factor of 4. So if you look at the numbers, the constants and the coefficients, you have 4, 2, this is a 1 right here, and 4. So what's the smallest number that 4, 2, and 4 go into? Well, that will be 4. So far, my least common denominator has the factor of 4. Now look at your variable. So this is a factor of x, this is a factor of x, so I need x. And it makes sense because 4x goes into 4x, 2 goes into 4x because 2 goes into 4, x goes into 4x because x goes into x, and then 4 goes into 4x because 4 goes into 4. Okay? So that's the least. All right, it's always easy. It's always best to use the least. Now, if it says find the least common denominator and you use a common denominator and it's not the least, then you're going to lose some points. So if it says to use the least common denominator, then you must use the least common denominator. Okay, so now let's find the restriction. So to find the restriction, that's the easy kind when the denominators are monomial factors, because all you're asking yourself is, remember, the restriction is the value of x that makes this rational expression, that makes this fraction undefined. So a fraction is undefined when the denominator is 0. So 4 times what is 0? Well, 0. So there's one of my restrictions, x not equals 0. Over here, there's no variable here, so that means that this is always going to be a 2. It's never going to be 0. Over here, what makes this 0? Well, when x is 0, and we already have it. Here, that's a constant. That's never going to be 0. That's always going to be 4. And so there's my restriction. You could have also done this. You could have said, well, if my least common denominator is 4x, then let's go ahead and set that equal to 0. And so solving for x, I'm going to divide both sides by 4, and so I get x to be 0, and there's your restriction. All right, but most students, because you could have made a mistake here, so most students just go ahead and determine, based on this, what makes this 0, based on this, what makes this 0, based on this, what makes this 0, based on this, what makes this denominator 0. Okay, so all these denominators, you want to find out what makes them zeros. Okay, now once you find the least common denominator and the restriction, you want to multiply both sides by the least common denominator. Notice, though, there are two fractions in each side. So let's go ahead and put those in parentheses, and we're going to multiply by 4x. So 4x times x plus 2 divided by 4x minus 3 halves. So this left side is being multiplied by 4x, and this right side is also being multiplied by 4x. All right, so once you introduce parentheses or brackets in this case, let's go ahead and distribute. So we're going to go ahead and get rid of those parentheses or brackets, whichever one you used. So you're going to say 4x times the first fraction, x plus 2 divided by 4x, minus 4x times the second rational expression, 4x times 3 divided by 2, equal on this side, 4x times the first rational expression, 4x times 5 divided by x, minus, subtract, 4x times the second fraction or rational expression. Okay, now notice what you want to do, keep in mind, is once you find the least common denominator, you want to multiply both sides by the least common denominator to clear the fractions. So at some point, you're going to notice that you're not going to have these denominators. They're all going to be factors of 1s. Okay, so the whole point of multiplying both sides by the least common denominator to clear the fractions. And now you can see where we're doing that. 4 into 4 is 1, 4 into 4 is 1. X and x is 1, x and x is 1. So notice I have 1s now. Over here, 2 into 2 is 1, 2 into 4 is 2. Notice I have 1. X and x is 1, x and x is 1. Notice I have a factor of 1. 4 into 4 is 1, 4 into 4 is 1. Notice I have a factor of 1. Okay? All right, now, to go from here to here, you're going to do this. You're going to say 1 times x plus 2 is x plus 2. Subtract 2 times x times 3. 2 times x times 3 is 6x. Equal. Over here, you have 4 times 1 times 5 is 20. Minus 1 times x times 1 is x. All right, so notice I have this linear equation. So I went from a rational equation to a linear equation. And to solve this linear equation, we're going to bring all the variables one side, constant to the other. But before I do that, let's go ahead and combine like terms on this side, because notice I can combine the x and the negative 6x. So x and a negative 6x is a negative 5x plus 2 equal 20 minus x. And let's just go ahead and bring the variables to the left and the constants to the right. So to bring the variables to the left, the next thing, if you notice I'm subtracting x, the opposite of subtracting x is to add x. So I'm going to go ahead and add x to both sides, and then let's combine like terms. A negative 5x plus x is a negative 4x plus 2 equal, when I combine like terms, these add up to be 0, because negative 1 plus 1 is 0, and then 20. So negative 1, the coefficient here is negative 1, the coefficient here is positive 1, negative 1 plus 1 is 0, so therefore negative x plus x is 0. Okay, the next step is to subtract 2 from both sides, because remember you want this to be a 0, so you gotta add the opposite. So adding 2, the opposite is subtract 2. But what I do to one side, I do to the other. So notice at each step, you got to show this. Okay? Then let's combine like terms. So this is going to be 0. So I get negative 4x and 0 is negative 4x equal. And then 20 subtract 2 is 18. And then to get x by itself, right now I'm multiplying by negative 4. The opposite of multiplying by negative 4 is to divide by negative 4. And so negative 4 divided by negative 4 is positive 1. 1 times x is x. So notice I want to get x by itself. Equal. And then remember, positive divided by negative is a negative, but you want to reduce. So 18 fourths they're both divisible by 2. So it'll be 9/2. Now, remember, you got to check your restriction. So is this, remember, this is a solution to the linear, but it may not be a solution to the rational equation, the original. So you got to check your restriction. So notice that -9/2 is not my restriction. So assuming I did all this work correct, this is the solution. So if I were to substitute this into the original, the left side will equal the right side when I substitute x equal -9/2. All right, so that's number 2. Okay, let's look at number 3. So number 3, we have this rational equation. And notice that this rational equation have all these rational expressions: 1/3, -2 divided by x, +1/6, and then 2x plus 1 divided by 3x. Notice also that these denominators are all monomial factors, so there's nothing to factor. So those are the easy kinds where you have a rational equation where the denominators are monomial factors. It's pretty easy to determine the least common denominator. So if you look at your constants and your coefficients, here my constant's 3, my coefficient here is 1, my constant is 6, my coefficient is 3. The smallest number that 3, 1, 6, and 3 go into is 6. Now the variable, notice that this denominator has a variable x, this denominator has a factor of x, and so therefore I need x. And again, 3 goes into 6x because 3 goes into 6, x goes into 6x because x goes into x, 6 goes into 6x because 6 goes into factor 6, and then 3x goes into 6x because 3 goes into 6 evenly, and then x goes into x evenly. Okay? The restriction, same as before. So if you look at these are all monomial factors. This denominator is never going to be 0. So remember, finding the restriction, you want to determine what makes this expression undefined. Well, a rational expression, a fraction, is undefined when the denominator is 0. Well, that's always 3. See, there's no variable here. So that's always 3. So there's no restriction here. Over here, though, there's a variable x. So when is this denominator 0? Well, when x is 0. If I substitute 0 for x, it's 0. So x not equals 0. You got to do all of them, though. So here, that's 6. It's never going to be 0. Here, 3 times what is 0? Well, 3 times 0 is 0. And I already have it listed. Okay, so the next step is to multiply both sides by the least common denominator. So you're going to say 6x, and again, since I have two fractions here, two rational expressions, let's go and put that in parentheses. So I got 1/3 minus 2 divided by x equal, and then the same thing, what I do to one side, I do to the other. So if I multiply the left by 6, I have to multiply 6x. I have to multiply the right-hand side by 6x. And then so I got 1/6 plus 2x plus 1 divided by 3x. Okay, now notice though I did introduce some parentheses, so now I have to get rid of the parentheses using the distributive property. And so I get 6x times the first fraction minus 6x times the second rational expression equal, and then the same thing here, 6x times the first rational expression plus, and then 6x times the second rational expression. Okay? All right. Now, so remember the whole point of multiplying the both sides by 6x is to clear those fractions. So make those factors all factors of 1. And then now you can see it happens because 3 divided by 3 is 1. 3 into 6 is 2. Over here, x and x is 1. X and x is 1. So you get factors of 1 in their place. Here, 6 into 6 is 1. 6 into 6 is 1. Here, 3 into 3 is 1. 3 into 6 is 2. X and x is 1. X and x is 1. All right, now let's go ahead and rewrite this to make it look better. 2 times x, this is, okay, this is multiplication right here, so be careful. It almost looked like a subtraction. So 2 times x times 1 is 2x. Subtract. 6 times 1 times 2 is 12. Equal. 1 times x times 1 is x. Now let's be careful here. So you see where this numerator is not a monomial. it's a binomial, so you need to put that in parentheses because this 2 times 1 here, which is 2, this 2 has to be multiplied by all of these. So you're going to say 2 times 2x plus 1. If you don't do that, you're probably going to get an error. You're going to have, when instead of having 4x plus 2, you're going to have 4x plus 1. So automatically you have an error. So if it's not a monomial factor, the numerator, put in parentheses, just like I did. Okay, now let's go ahead and distribute. So I get 2x minus 12 equal x, and then if I distribute the 2 times 2x is 4x, so plus 4x, and then 2 times 1 is 2. All right, so notice I use the distributive property 1, 2, 3 times. Okay, now let's combine like terms. So notice I now have a linear equation. So I went from a rational equation to a linear equation. So this is now linear. And to solve a linear equation, we eventually going to bring all variables one side, constant the other. But before I do that, let's go ahead and combine like terms on this side. So 1x plus 4x is 5x. So I get 2x minus 12 equals 5x plus 2. And then let's just go ahead this time and bring all the variables to the right and then the constants to the left. So if I'm going to subtract, so in this case, to get rid of the 2x, you have to subtract 2x because 2x and a negative 2x is 0. But what I do to one side, I do to the other. So let's go ahead and align like terms. Now we're going to combine. This is 0. 0 and a negative 12 is a negative 12 equal 5x minus 2x is 3x plus 2. Okay, now we've got to bring this constant to the other side. So right now I'm adding 2. The opposite is to subtract 2. And then let's combine like terms. So notice what you do one side, you do the other. A negative 12 and a negative 2 is a negative 14 equal, this is 0 because 2 and a negative 2 is 0. 3x plus 0 is still 3x. And then finally to get x by itself, right now I'm multiplying by 3. And the opposite of multiplying by 3 is to divide by 3. And so 3 divided by 3 is 1. 1 times x is x. And I get negative 14 thirds. I cannot reduce this, but if you want to, you can write it as a mixed number since it's improper. So you can write this as negative 3 goes into 14 4 times. Remember what you're doing is this, 3 into 14 goes 4 times. 4 times 3 is 12, remainder 2. So you get 4 and 2 thirds. So negative 4 and 2 thirds. You can always check because 4 times 3 is 12. 12 plus 2 is 14. All right, so that is the key to the worksheet dealing with topic 2, part 1.